Samuel owns a printing machine. The printing machine is depreciated using a flat rate depreciation. So they told you flat rate. So you need to highlight that. Make sure you're using flat rate formulas. The value of the machine after n years, this is also important, okay, can be modeled. By what amount does the value of the machine decrease each year? So they said amount. So you should be able to read the recurrence relation here and tell me how much does it drop by the rule every year it's taking away 15,000. So we're just reading it off there. Showing recursively, so here's where I told you they're going to say showing recursively, determine the value after 2 years. So they want you to get to V2. So you are only going to get this 1 mark, if you have exactly this. So you got V1, you write 120,000 minus 15,000 equals 105,000. Then you show V2 is that 105,000 minus 15,000 equals 90,000. So unless you write that all of that out, you're not going to get that 1 mark. So the next one, the annual flat rate. So we want rate again. So we can use, we did see in our notes a formula. We had that R equaled the D value over VO times 100. So let's use that formula here to find the annual flat rate. The reason I rather use this formula rather than solve is because if you're asked to show how the flat rate is the answer, you need to do this one. So we knew D was 15,000, VO was that, times 100 equals 12.5%. Okay? So this would work if you were asked to show that the rate is 12.5%, you have to use that formula. But because they just asked, okay, so you could have, because this one didn't say show, you could have or solve. But I think, obviously if we use the show way every time, we know we won't have to change what we do. They don't want to see solve when they ask you to show. So there you go. You would have still got 12.5% just to show you that that's how, because maybe you don't see it on the day. So, all right. So the next one, it says the value of the machine after n years could be determined using the rule. So remember when they say using rule, that means nth term. So we're using flat rate and nth term. And you can see that if I wrote that, if I'd gone to my notes, I would have seen flat rate formula is this. So, you know, if you look here, it says write down what the values, write down the rule for VN, and it said to just put it in this format, which is the same as our format anyway. So we're going to go VN equals, so what was VO in this scenario? 120,000, I believe. And then I'm just going to say minus. Now they're telling you to put the number first. So D was 15,000 and just times N. Okay. So it will make your life will be a lot easier if you start like writing what I'm saying. I see rule, I say nth term, I'm using flat rate. I just go to my notes. All right. With this one is how I told you. You don't get asked to draw graphs. You get asked to interpret them. So I want to have a look at this graph, but I'm going to come back to that after we've done a few more chapters. So we're just going to skip over that one today. We'll come back at another later date. And let's go to this one. Okay, so it says Barb drives a company car bought for 50,000. So you can see up here they've put 50,000. So that was my VO. She depreciates the value of the car for 20 cents per kilometre that it travels. So that's a unit cost. sort of, that's a unit cost scenario. And you know that's always like a same amount. Now, on the graph below, 4 points that represent the value of the car after Barb travels. They want you to graph it. So they want you to graph what it's worth at 20,000 Ks, 40,000, 60, and 80. So because it's unit cost, but you want to find after so many uses, you probably best, you could use the nth term formula for unit cost. So we know that's Vn equals the VO, which is 50,000, minus the cost per use, which was 20 cents per N. So if I wanted to know what, I'm just going to say when N equals 20,000, so I pop that into my formula, the value would be 50,000 minus 20 cents times 20,000. And I end up with 46. So I go up here and I go, I think these were in 2000. So you do that and then you do it for when N equals 40,000. You do the same thing and you'll find the value is 42. So you go up to there and it's 42 there. And then you do it when 60,000, you'll find the value is 36. So you go up the here 246, there you go, and then the last one 80,000. Now the value is 34. Now it should be a straight line. So when you draw it on your, if you put a rule, 30. What did I say? 34. If you put a ruler across your lines, you would see that it should be a straight. I think I'm a bit cuckoo, but there's the answer. So it should go straight across. All right. Now a lot of these marks are missed, and see up there. This one would have been poorly done, and it's generally because kids just skim over it. So a trick of the exam is to always circle like the mark and go, did I answer that mark? Where's that mark? And so then you would have seen I've missed one, yeah? Because you come down here, here's the next question. So that one mark is for this. So you'll hopefully you can look and go, oh, where's that? So to complete the rule that gives the value of the car, so we know that means nth term. We've already worked that out because we had to graph it. So I can simply put in those numbers that I found. So nth term, 50,000, and it's minus. Once again, they've been nasty. They put a plus there. So that means I have to have minus in the thing. You don't have to have, we should put 0.20 because we're talking about money, but I don't think you would technically be wrong if you had 0.2. That's the minus needs to be there and the 0.2. So there you go for that. So that's the trap. They're just being nasty so that they can slip up people. So Barb travels 20,000 kilometers each year. The value of the car could be considered to be depreciating at a flat rate. So flat rate and unit cost, they do look the same. So what is the annual rate? So that is the R is the question. And so we're at flat rate. So remember, we could go use that formula I said before where we just take D and we do that. And remember, I said this one's a better one because this could be used if they wanted me to show it. So we are dropping, if you have a look, how much does it drop in 1 year? So she's traveling 20,000 kilometers a year. So 20,000 times 0.2 equals 4,000. So it drops 4,000 each year. So that would be D equals 4,000 in flat rate, yeah? So now we can put that in here. So 4,000 divided by VO, which is 50,000, and times by 100, and we end up with 8%. 8% rate. That's your answer. So that is important. Like I would say, this formula, make sure this is, if it's not on our summary sheet near flat rate, maybe pop that near that because it's going to be helpful. Okay, the next one. Pina owns a workplace equipment. It depreciates using flat rate. So we're going to always start underlining this. Flat rate. There's the value of the equipment. So this is nth term. Yeah? This was the value of the equipment after n years using the rule. So that's why I knew it was nth term. Determine the value of the equipment after 1 year. So that was the value at any time. So we just want the value if n equals 1. So it'd be like that. So we end up with 187,500. So there you go. After how many years will the equipment have the value of 0? So value equals 0. So this is where we could use solve. Because we want it to be 0. So I could use solve here, comma n, and we end up with 16. So you better answer the question. It says after how many years. So it's all right as long as you say, you don't have to say after 16 years, but you do need to either box that answer, like so to say that it's 16. The value of the equipment in dollars after n years can also be modeled using recurrence relation. So now we want recurrence relation, remember, and we're on flat rate. So go to your formula sheet. We know for recurrence relation, we have to write the initial value. Now up here, remember nth term, that is VO, so I've got that. And then the n plus 1 rule is Vn minus the D value, which I can also see up there from the nth term rule. There you go. And there's the recurrence relation. And what I'm going to do, this is going to be what we're going to lead into. So we will do this. I'm just going to read this to you and I'll tell you the answer. You would not know this yet. Using Pina's depreciation model, the value of the equipment decreases at a fixed percentage of its original value. So this is like linear decay, yeah? Or flat rate. Now what it's saying is, alternately, the value of the equipment could be depreciated using a fixed percentage, but off its value every year. So that means it's going to take it off a percentage of the new value every time. So this is like geometric. This is geometric, which we're going to learn about soon. This is geometric decay. And what that one's called is called reducing, because it said, what is that method called? It's called reducing balance depreciation. And we'll learn about that in the next couple of days. All right. So let's just pop that in, and that's why we were leading into that. So